In today's daily dose of math, I'm going to graph a step function, a greatest integer function. And this is the one I'm going to use as my example. A is -2, B is -1/4, H is 3, and K is 6. But I'm going to try graphing this using a table of values by trial and error instead of by using the parameters. Use of parameters will be a different video. This is a good way to become familiar with how this type of equation works. Remember, there's just one thing about the step function that's really new. We have multiplications, we have brackets, subtractions, we're graphing points onto a coordinate plane. All of this is a review of things that we've done with other functions. But the square bracket is the new thing. The way I would deal with the square bracket is I always think about what it means. The square bracket means the greatest integer less than or equal to. If you remember that, if you know what it means, that you're looking for the greatest integer to the left on the number line from the number you have inside the bracket, then it becomes easy to understand why the function takes the shape that it does when you graph it. Let's get into this, and I'm going to start with x equals -1. Well, we have -1 minus 3 in the bracket, and that turns into -4. The -4 is being multiplied by this -1/4, and that turns into +1. The entire portion that's inside the square bracket is equal to +1. And then I apply the meaning of the square bracket. What is the greatest integer less than or equal to 1? And it is 1. So the entire portion, including the square bracket, is equal to 1, which is then multiplied by -2 to give -2, and then we are adding 6 to it, and we get 4. Once I go through this process with x equal to -1, I get y equals 4. -1, 4 gives me a point right about here. And I'm putting a small point because the step function we graph with bars, and we need some large open circles and closed circles on the ends of those bars. All the other points join together to form the bar, the step. If x is 0, I go through the same process again, but I'm not going to write it out this time. 0 minus 3 is -3. -3 times -1/4 is +3/4, or 0.75. The greatest integer less than or equal to 0.75 is 0. 0 times -2 is 0, and 0 plus 6 is 6. So my y-coordinate will be 6. Quickly, let's do a couple more and see what happens. If x is 1, 1 minus 3 is -2. -2 times -1/4 is +0.5, or +0.5. The greatest integer less than or equal to that is 0 again. 0 times -2 is 0, plus 6 is 6. We get another 6. Get used to this happening when you're doing a large table of values for a step function. If x is 2, 2 minus 3 is -1. -1 times -1/4 is +1/4, or +0.25, and the greatest integer to the left of that on the number line is 0 again. 0 times -2 is 0, plus 6 is 6. 3 minus 3, something different is happening finally. 3 minus 3 is 0. 0 times -1/4 is 0. The greatest integer less than or equal to 0 is still 0 though. 0 times -2 is 0, plus 6 is 6. We have yet another point where the y-coordinate is 6. I've left some space because it's instructive and useful to consider points that do not have whole numbers for their x when you're dealing with a step function. But if x is 4, 4 minus 3 is +1. +1 times -1/4 is -1/4, or -0.25. The greatest integer less than or equal to that on the number line, though, is -1. -1 times -2 is +2, plus 6 is 8. Now I'm going to jump over 5 and 6 because I see this repetition happening. And I'm going to try 7. 7 minus 3 is 4. 4 times -1/4 is -1. The greatest integer less than or equal to -1 on the number line is -1. -1 times -2 is +2, plus 6 is 8. If x is 8, 8 minus 3 is 5. 5 times -1/4 is -5/4, or -1.25. The greatest integer less than or equal to negative 1.25 is negative 2. Negative 2 times negative 2 is positive 4, plus 6 is 10. So we're able to see our steps. We can see that we're jumping up 2 units on the y-axis whenever we climb a step. And we're getting an idea of how long our steps are. This portion of the table of values shows that the steps are at least 3 units in length. I want to know what happens between 3 and 4, because I want to know what happens when the step goes from y equals 6 to y equals 8. So I'm going to use 3.1. 3.1 minus 3 is 0.1, or 1/10. 1/10 times negative a quarter is negative 1/40th. The greatest integer less than or equal to negative 1/40th on the number line is negative 1. Negative 1 times negative 2 is positive 2, plus 6 is 8. So what's happening here, as I have deduced, that as soon as we pass 3 and get to a number slightly larger than 3, our y has jumped up the step. So that tells me that 3 is the place where I need both an open circle and a closed circle when I graph this. I'm going to catch up on putting my dots on the graph now. 0, 6 is here. 1, 6. 2, 6. 3, 6. And that's where I know I need a closed circle. Because as soon as I go past 3 on the x-axis to 3.1, I'm getting a point where y is 8. So that tells me I need an open circle right there. And I can start drawing in my step, drawing in my bar. I want to see what's happening here, in between x equals negative 1 and x equals 0. So I'm going to put into this space in the table negative 0.5, negative a half. Yes, it's not arranged in the place you'd expect to see it, but I'm going to plunk it in there in the table. Negative 0.5 minus 3 is negative 3.5. Negative 3.5 times negative a quarter is positive 7/8, or positive 0.875. The greatest integer to the left of that on the number line is 0. 0 times negative 2 is 0, plus 6 is 6. We get another point with the 6. So what this is telling me now is that 3 and negative 1 are spots where we are jumping up a step. So therefore, this is one of my solid circles. I'll move this 6 label to the left out of the way a bit, and right there I put an open circle. I have finished my first step. I know that this one will continue in this direction, so I'll draw out a little bit of it. And I now know that the steps are 4 units in length. So therefore this one, which starts at x equals 3, will continue to x equals 7. And then I need to go up 2 units on the y-axis and put an open circle, and I can start drawing my next step. I have graphed my step function, and I have discovered some things by doing it trial and error. I discovered that the steps are 2 units in height, that they're 4 units in length, that the closed circle is on the right side of the step, and the open circle is on the left side. So I have succeeded in graphing this function. Now the problem with this is that it took a long time. If we use the parameters, we can do it much faster. So be sure to watch another video that I'm making that shows me graphing the same function, but using the parameters instead of a table of values. That is today's Daily Dose of Math. Please like, subscribe, and share.